Alright, this is EUS 5 day 6. What I'd like for you to do is go ahead and do this. This was the warm-up. Just a quick review. So if you will pause and go ahead and do that, I'm going to go ahead and put the answers up here now. When you're multiplying, you add your exponents. Power to a power, you multiply. This you're just going to multiply 5 times 3 is negative 15. Add your exponents again. Anything to the 0 power is 1. This problem, negative exponents change location. The 2 is not with it, so it stays in the top. The z does not have a negative exponent. It stays on top. The x to the 5th and the y to the 3rd come down to the bottom. You make them positive. Here, a power to a power will just have x to the 20th. 2 to the 4th power is the 16th. Couple ways you can do this. I usually move everything first, so that's 1 over 5 x to the 4th y to the negative 3 squared. So we moved it all down. 5 squared is going to be 25. Y to the 4th squared, you're going to multiply, you get, x to the 8th. And y to the negative 6 means it's going to go up to the top. You're going to have y to the 6th on top. Alright, so a quick review of those. Now, know your fraction math. You need to get a common denominator when you add and subtract, but not for multiplying, or really dividing. Okay? So, if you look at the first one, try to decide what your common denominator is going to be. What number will both 8 and 10 go in? And they both go into 40. So that's going to be my common denominator. What do you have to multiply 8 times to get 40? On a good day, that's 5. So whatever you do on the denominator, you have to do the numerator. So we get 25. This side needs a times 4. So 1 times 4 is 4. So now when they have the common denominator, you can add 25 plus 4 is 29 over 40. Number 2. What is the smallest common denominator between 18 and 12? That's not the easiest number to do, but it's 36. So 36 is going to be my common denominator because 2 times 18 gives you 36, and 3 times 12 gives you 36. So if I multiply 2 on the bottom, multiply 2 on the top, we get 10. 3 on the bottom, 3 on the top, 3 up there. So we get 13 over 36, and at first that looks like that should simplify, but it does not. Here, 10 and 15, think what number they both go into. The smallest one would be 30. So the 10 you're going to multiply times 3, the 15 you're going to multiply times 2. But whatever you do in the denominator, you do in the numerator. We get 27 minus 8. 27 minus 8 is 19 over, oops, I'm going to make that a 20, it's 30. And last, 2 and 8. Well, actually, 8 is going to be your common denominator, so this side we're not even going to have to change. Oops. This side, to get the 8, you need to multiply by 4 on the bottom, so 4 on the top. So 7 minus 4 is 3 square root of 8. 3 over 8. No square roots. Not right now. Alright, those are probably the hardest ones, adding and subtracting. When you multiply, you don't have to get common denominators. And on these, I would cancel first. You can multiply straight across and then reduce, but I'm going, hey look, there's a 10 on bottom, a 2 on top. Why not cancel these guys out? 2 goes into 2 once, goes into 10 5 times, and we get 7 over 25, which is much easier to cancel first. You could multiply straight across and get 14 over 50, but then that reduces down to 7 over 25. So number 6, I would cancel again. I see the 8 and the 12. As long as one number is on bottom and one's on top, 4 goes into 8 twice, 4 goes into 12 3 times. So we get 9 over 14. Like I said, the multiplying is a lot easier. No common denominators. On this one, nothing simplifies, right? You can't reduce any of these, so it's just 3 over 32. And the last one, oh, look at that. The 3's cancel. 3 goes into 3 once, 3 goes into 3 once, 2 goes into 2 once, 2 goes into 4 2 times, and you end up with just 1/2. That was a quick review because we're going to use that later on in the lesson. Okay, this whole next box, basically, folks, it's just a review. We can take square root of 8. Because remember, that is 4 times 2, so it is 2 radical 2. We do that one so much, you guys are getting good at that one. Now, we've not been doing negative inside for these problems, but they do exist, right? This would just be 2i square root of 2. Square root of 1 is, 1. Square root of a negative 1 is just I. Remember, that's really our definition there. And let's do what happens if we put numbers in? Remember, we're doing square roots. How many sets of w can you take out? 6 divided by 2 is 3. We can take out 1x. Okay, here are the y's, it's an odd number. So what's the closest even number is 4. So that means we can take out 2, and we're going to have 1y left inside. With the z's, the same thing. The next even number down is 6. So 6 divided by 2 is 3 z's, and then we'll have 1 z left. Quick review of those. Cube roots. Okay, what happens when you take the cubed root of 8? It's not 2 radical 2, because that's just an even 2, because 2 times 2 times 2 is 8. And this is not imaginary, because remember, we can do cube roots of odd numbers. This is actually a negative 2. This is 1. This is a negative 1. And remember, we practiced doing other roots. What number times itself 4 times gives you 16? Yep, 2. What number times itself 5 times gives you 32? Yep, 2 again. And what number multiplied times itself 4 times gives you 81? No, it's not 2. Do you know? It is 3. All right, so I know you're saying, okay, I'm ready for some new information. Well, by golly, here we go. Here's the new stuff. You may not remember, but you've probably been taught at some point that a rational number is a number that can be written or is written as a fraction. So 1/2. It's a rational number because it's written as a fraction. 12 is also a rational number because you can write it as 12 over 1. Okay, so any rational number is a number that can be written as a fraction. Also 1/3. There you go. Okay, so here's the interesting part of the day. Exponents can be rational numbers as well, which means exponents can be fractions. So we're going to practice converting exponential notation, that's when you have an exponent, to radical notation. So this over here is your exponential notation. Why? Because it has an exponent. This is your radical notation because it has the radical sign in it. And sometimes it gets confusing to know what goes where. So flower power, it sounds silly, but this is what helps us remember where things go. Flower power. All right, so if you look, here's your ground level, right? This is the line of your fraction. What goes on top? What is on top? It's your flower, which is your power. This is the 5th power. This is what goes on top. What goes on bottom? This would be the roots, like a square root, or these, remember, we also call them the index. So if you look over here on your fraction, this is your power. This is your index or your root. So when you rewrite it, look, here it is. The bottom number is your little index. It goes there. Your power goes right there. So all we're going to do right now is just take a minute and practice writing each expression in radical form, because see, these are all in exponential. So the first one, the 4 always goes inside. It's your radicand. Put your radical around it. 5 is your power. It goes out here. 2 is the index. So you can put it right there, like that, or you can just write it like this. Remember, if the 2 is not there, we know it's a 2. Okay, over here, if you've got this, go ahead and stay ahead of me. 8 goes inside. This is a cubed root. Your power is just 1. Do I need to write that out there? Nope. So you don't have to. You can just leave it like it is. So go ahead. Try these last two. I'm just going to work them out here, and you check them as you do them. I'm not going to put my square on the last one because I know that that's a square even if it's not there. Okay, now these bottom row are already in radical form. We're going to put them in exponential form. Now if you noticed on 5, you can write them with the parentheses, with the 11 on the outside. If you put the 11 on the inside, you will actually get the same answer. So don't let it freak you out. 11 is still the power, whether it's put inside or outside. And if you don't believe me, grab your calculator and punch it in. So no matter how you write it, 7 is your base. It's the radicand on the inside. 6 is your index. It goes on bottom. 11 is your power. It goes on top. 6 is your base. 7 is your power. 4 is your index, your root. And go ahead and try those last two. I'll try to be quiet. I didn't stay quiet very long. Remember, if there's nothing there, it's a 2. And if there's nothing out here, it would be a 1. Okay, so pretty easy. We're just practicing going from one form to the other. Now we can do the fun stuff on the back side. Yeah, I think it's fun. I'm a math teacher. Probably a little nerdy, but I'm okay with that. All right, we're going to evaluate without a calculator. Okay, so the clue, which I gave it to you here, is to rewrite in radical notation. Okay, see, this is in radical notation already. We're good. We don't have to do anything there. So let's look inside the parentheses first. What is the cubed root of 8? We already did on that on the other side, right? The cubed root of 8 is actually 2. And now we have 2 squared, which is 4. And that's your answer. Wasn't that fun? All right, let's look at this one. What number times itself 3 times would give me 27? We've done that one quite a bit. That should be 3. And I still have the 5th root there. So 3 to the 5th, it's a big number. I'm okay if they're huge that you leave them like that. But if you have a handy-dandy calculator, which we're supposed to be doing with these out the calculator, then we definitely leave it at that. But if you grabbed your calculator, it's 243. So try the other one. Figure out what number times itself 4 times gives you 16. Yep, it is 2. Hope you said that. And then we cube it, and 2 cubed is 8. So I will be quiet on the last one. You try to work it out. Oh, look though. This is an exponential form. Hint, write it in radical notation. Okay, so let's switch this to radical notation. Index. Power, square root of 4. I said I'd be quiet, didn't I? I'm not very good at that. And 2 to the 5th power, it's 32. All right, so now we got a few more, and these are already all in exponential notation. So again, rewrite it in radical notation. So rewrite this one. So I think we did this one on the other side. Oops, get my paper where you can see. The 4th root of 81. Didn't we do that one? Right there it is. The 4th root of 81, it's 3. Okay, so now we have 3 cubed. That is not 9. What is it? Correct. 27. I know that's what you said, so we're good. Next one, rewrite it. It's your radicand, index, power. We can take the cube root of a negative number, right? We did this one on the other side too. It's negative 2. And when you square it, you get a positive 4. See, I told you, these are fun, aren't they? Now this one you can actually do two different ways. We're going to go ahead and just rewrite them, because that's what we were talking about. 64 goes inside, 64 goes inside. My power is 1, my index is 2. Power is 1, index is 3. We know the square root of 64, that's easy, that's 8. Cubed root of 64 is a little harder, we don't do it as much, but I bet some of you know. It is 4. So 8 times 4 is 32. There is another way we could do that. We're going to talk about that down there, but we'll do it that way for now. What do we do if we have a fraction? Same way. This is your radicand. Put it inside my exponent, or my index is 2, my root. My power is 3. So, hey, we know the square root of 9. That's 3. The square root of 25 is 5. That was easy enough. Now cube those. And 3 cubed is not 9, remember, it's 27, and 5 times 5 times 5 is 125. So, I know some of you are going, how do you know those so quickly? Because we use them a lot. So some of you, I'm just going to give you a quick cheat sheet here so you've got these. Anything to the 0 power is 1. It is not 0. Do not say that. Check that in your calculator if you haven't. 2 to the first power is 2. Times 2 is 4. Times 2 is 8. Times 2 is 16. Times another 2 is 32. And times another 2 is 64. Boom, got those. And anything to the 0 power is still 1. 3 to the first power is 3. 3 times 3 is 9. Times 3 is 27. Times 3 one more time is 81. So you'll have those for quick reference if you need them. Alright, last part of our lesson. We are going to simplify these using rational exponents. Okay, we have done this before when you have x to the third times x to the fourth. What do you get? You add them, right? So we get x to the 7th. What are we going to do down here? We are multiplying, so we are going to add our exponents. And man, I was really nice. Look at this one. They already have common denominators. So, most of you don't need to rewrite this, but I'm going to show you so you can see exactly what we're doing. We're going to add our exponents. The denominators are already the same, so our answer will be x to the 1 plus 4 is 5/8. And that's our answer. Just leave it. Okay, we have another one. We're multiplying, so what's the rule that we do? We're going to add the exponents there too, right? So now, and I'm just going to, we have x to the 1/4 plus 5/6. So what I'm going to do is I'm going to come over here to the side and do the work for getting my common denominators. We have 1/4 plus 5/6. What's my common denominator between 4 and 6 going to be? What number do they both go into? Easiest one would be 12 is what I'd do. So if 4 times 3, so 3 top and bottom, 6 would be times 2. So 3 times 1 is 3, 5 times 2 is 10. So now I'm going to add that and get 13/12. So when I add these two guys, I get for my answer x to the 13/12. Yes, it's an improper fraction. I'm okay with that. You can leave it. Alright, what do we do when we have a power to a power? What's our rule? Are you saying it? Yes, we multiply. Do we need common denominators? Heck no, we don't. So I'm going to go y to the 2/3 times 3/4. And oh wow, look, the 3's could cancel out. We just did one like this on the other side. 2 goes into 2 once, 2 goes into 4 twice. What are we left with? Y to the 1/2. Yes, that is it. Told you, these are fun too, aren't they? Alright, we're down to the last two problems. We have a division. What do you do with your exponents when you have a division problem? Do you remember the rule? I'm hoping you said we subtract our exponents. So, we have x to the 3/5 minus 1/5. And they have common denominators. Oh, I love when I do that. So the answer is just going to be 3 minus 1 is 2/5. We're down to the last problem. It's another division, so I'm going to subtract. What do I do if there's no exponent? Well, what is there if there's nothing there? It's a 1. Okay, so we're going to go p to the 1 minus 1/3. Obviously, some of you could do that in your head, but I'm going to go ahead and get common denominators. So you make your 1 would become 3/3 minus 1/3, which would leave you 2/3. So p to the 2/3 is the answer. And that, my friends, is the end of our lesson.